Friends, in this video, I'll be explaining the universal set, the unit set, and the empty set for you guys. Now, at first, what do you mean by universal set? Let's say we have a particular secondary school, and in that particular secondary school, you have the junior classes and also the senior classes. You see, the combination of the junior classes and also the senior classes, the combination of the two is what we mean by the universal set. That is the total number of every student in that school, the total number of us of the sets in that school is known as what? The universal what? Set. And let's say let's take 100 level students for example now. The total number of all other level students as far as university is concerned, that's a set. That's a set. The number of 200 level is also a set. The cardinality of 300 level is also a set. 4 levels is also a set. 500 levels is also a set. Now, if we're not talking about the number of all the universities, of the total levels in the universities, is known as what? The universal set. Now look at this. The universal set is the set which contains all possible elements under consideration. It is called what? The universal set. It is the set which contain all possible elements. That is, it contains all the elements present in a particular unit set. Yeah, we have something we call universal set. We have unit set. Unit set is just a single set. All level student, that's a single set. So on level set is a single set. Then the total number of all the elements present in the what? In 100 level, 200 level, up to 500 level is what we call universal set. Now moving to the second statement. A set which consists of only one element is called a unit set. Yes, a unit set is normally denoted as what? Let's say you have something like this. How is my pen on writing? You have something like this. Yeah, you have x inside. Can sit down. Everything here, this is called what? This refers to a unit set because inside it you have just single element. We have a single element inside it. But as far as universal set is concerned, universal set can be something like the set of all real number, set of all real number, set of all alphabets. Guys, I know in an alphabet you have almost like 26 letters in an alphabet. Now, bringing out the unit letter out of the all alphabets, if I want to bring out the unit set now, I'll say if I have a vowel letter, a consonant letter, or a consonant letter, vowel letter represents what? A unit set, and while consonant letter represents what? A unit set. But we are talking about the universal set generally. We are talking about the total number of all the alphabets. Can I sit down? So that's just the total letters present in the alphabet. Now let's move to this next one. A set which contains no element is called the empty set. Yes, a zero element is known as what? Zero set is known as the null set. She get down. And null set is usually denoted as what? As something like you have a brace in the bracket 0 or something like this. This is what you have. What you have something like this. This is your null set, or you have something like this. This is what? A null set. Now, as far as the null set is concerned, it is denoted as what? As something like this. Look at so. It's either you find it like this or you use this sign. This is your universal set, and this is what? Your universal set. Now let's check example here. Human beings with tails. Now, you look at this now. Human beings with tails. Do we have any human being that have tail? No. Which is what? 0. So that this set is what? Is a null set. The second one. All months of the year beginning with letter B. Do we have all months of the year that begins with letter B? No. So this one is also a what? A 0, which is what? A null set. Then you have set C equals to what? You have two braces. You have enclosed 0 is enclosed into what? Inside two braces. Is this a unit set, universal set, or empty set? If you look at this now, if you have something like this is 0, but you haven't set C here. Can I sit down? Actually, you see this one. This is a unit set. It is called a unit set because at least this is O, not 0. O, letter O. You understand now? So let's say it is 0 now. That's why we call it a what? A null set, but it is what? A unit set because this is an alphabet, a letter. Now let's move to the second case here. We have the intersection of sets. What do you mean by intersection of sets? Let's say you have set A and set B. Intersection means what? Elements that are present in what? In A and also in what? In B. Most of the times intersection is actually known as what, as and. We call it and. If you see anything and, that's what, that's intersection. Now the intersection of two sets A and B is the set which consists of the elements that are in A as well as in what, and as in B. Now looking at this, theoretically the intersection is expressed as what, as S is a member of what, of A, and also what, X is a member of what, of B. This and indicates what, intersection. Now let me just bring them together. We have X is a member of what, of A, and what, X is a member of what, of B. So this and this sign is indicates what, intersection. That means intersection is denoted as what, as something like this, N. That's our intersection sign. Then let's check example. If universal set is what, all letters of the alphabet, A equals to F A K E, B equals to S P E A K, then we should find A intersection B. A intersection B means what, element that are in A, and also what, that are in what, in B. What I mean is that element that are found in what, in A, and so what, element that are found in B. Looking at this, F, that's not our intersection. You don't have X, you don't have X. We have E and A. E A K. That means our intersection will be what, E A K, because they are the what, they are the letters, elements that we can find in what, in both A and also what, in B. That's intersection. Then let's check the second case here. R equals to all positive even integers less than or equals to 20. That is all even integers, positive integers. That is, they are even numbered but they are positive. They are less than or equals to 20. That means our R in this case was R will be what? Okay, all positive even integers. That we have 2, we have 4, 6, 8, right? We have 10, we have 12, we have 14, 16, right? 18, and also 20. We are going to stop here because when she is all positive even integer that are less than or equals to 20. So this is it. Then and q equals to all factors of 20. Then our q, set q will be equals to factors of 20. Factors of 20 that was number that you can that can goes in what, in 20, that you can multiply them with another number that is going to give you what, 20. The first one is what, you have the 2, you have the 1 times 20 is 20. 2, you have 4, right? We have 10, we have 5, right? We have 5, and also what, we have 20. 2 times 5 gives 20. 1 times 20 gives 20. 2 times 5 20. 4 times 5 is also what, 20. Can you see that? So the question now says find out intersection Q. Our intersection Q means what, elements that are in R and also in what, in Q. Looking at this, elements in R and also in Q, we have what, 2, we have 4, we have 10. Do you have 10? Yes. Do you have 5? No. We have what, 20. So in this case, these are what, R intersection Q. Very simple. Now let's check the next case I'm having here. The next case means what, the union of what, of sets. If you're talking about union of sets means what, means elements that are in A or elements that are in what, in B. You know, if I want to talk about intersection, I'll say elements in A and elements in B. Can you see it now? But in terms of intersection is also known as addition. But you can just call it or elements in A or elements in what, in B. The union of a set A and B is the set which consists of elements that are either in A or what, or B, or both. That is, elements that are present in what, in A or B, or elements that are present in what, in both A and B, or in both A or B. Now looking at this, most times if you ask find union, you always use what, or, and it's also denoted as what, as something like this, which is, you call it union. This is U. Given that G equals to what, H-E-A-P, H equals to what, L-A-K-E, find G union H. In order for us to find G union H, G union H means what? Means elements that are in A or elements that are in B. Elements in A, we have H, right? G, H, E, A, P. Then here you have what? L, you are going to write it together. But take note of this A. You are not going to include A again. Since A is found here, they are not going to repeat it twice. Shall you get now? So in this case, you have what? K and also what? E. Can you say in short, it is just known as what? Addition. Actually, my E should not be there. E must not occur twice. A particular element must not occur twice when we are talking about union. If as far as union is concerned, you don't repeat element twice. So you have H E A P L K. That's our G union H. The next move to general exercise. The general exercise here, given that our universal set equals to all the letters of the alphabet, our x equals to a, e, I, o, u, and our y equals to e, b, c, d, f, and h. The first question says, find x union y. X union y means what? Elements in x or elements in y. Okay, coming back here, there is theoretical representation of union. In theoretical representation of union, you are going to have, let's say x is a member of what? Of G. Can you see that? Or x is a member of what? Of H. This or indicates what? Union. That means x is a member of what? Of G union H. Or you say, or similarly, you can say x is a member of what? Of G union x is a member of what? Of H. Can you see now? So these are the theoretical representation of what? Of union. Then moving here, you have to find x union H. X union H will be equal to what? Element that are in what? In x and also in what? Or y. That's A, E, I, O, U, B, right? C, D, F, and also what? H. You are not going to repeat it twice. Take note. Then the second one, you are asked to find x intersection y. X intersection y means what? Elements in y and also in what? In x. That is, elements that are in y and also in what? In x. Elements in y and also in x, we have what? E. I think it is only E. So that's E is their intercept, because E is present in x and also in what? In y. That's intercept. Then let's move to the third case. The third case here, x intersection y complements. No, y complements are elements that are not in y, but they are in the universal set. You understand that? They are elements that are not in y, but are in the what? Universal set. So we need to find our y complement separately now. Finding y complement separately, we have E, B, C, D, F, and also what? H. Can you see that? That means our y complement will be all other elements in the universal set except what? E, B, C, D, F, H. Can you see that? So in this case, this is how we are going to have A, right? A is not here. We are going to have I, we are going to have O, we are going to have U, we are going to have G, we are going to have T, right? We are going to have J, we are going to have N, we are going to have M, we are going to have N, right? We are going to have which other thing? Y, and so on, right? So in this case now, we are going and so on. So in this case, our x intersects y complements, that will be elements in what? In x and also in what? Y complements. Another than in x and also in y complement, just let us list them out. We have what? A, right? We have E. Can you see them? We have I, we have O, we have U. Can you see them? So that's just it. Can you see this now? Let's say y complement are elements that are in what? That are in universal sets, but they are not found what? In y. But if you look at this, x intersection y complement still means what? They are still talking about x only. You understand that? X intersection y complement still means what? X only. Because if I should write out all my y complement, this is my y complement. But the element that intersect, that are found in both x and also in y, is what? Is A, E, I, O, U, which is what? X only. That's just it. Then you see this number 4, you pretty want to solve it by yourself. Let me drop your answer in the comment box below. Thanks for watching. Now, I'm going to move to the final aspect of this theory, and that will be the Venn diagram and also the set notations. So, kindly subscribe to my YouTube channel if you haven't subscribed now. Subscribe right now and also hit the notification button. Thanks for watching.